Okay? So if you want the identity to be undefined, means the denominator has to be 0. Or any one of the denominator, either on the left or right, has to be what? 0. Now, that's one case. We also have cases where if you have tan in the identity, tan is undefined for all multiples of 90 degrees plus 180 degrees. What do I mean there? Okay, here you have to go back to your knowledge of trigonometric graphs. Okay, so for an identity to be undefined, the denominator must be 0. That's one condition. Right? The identity must be, so that the denominator must be 0. Then, if your identity has got tan, you also need to be aware that your identity will also be undefined for all multiples of 90 plus 180 degrees. Because if you remember, on a tan graph, at 90 degrees, there's an asymptote. 270, there's an asymptote. If you go to the negative side, which is what we are going to do in this grade, the negative side of the x-axis, you get minus 90 an asymptote, minus 270 an asymptote. Then you start adding 180 minus 450 an asymptote. Then you carry on and so on. All right? So, your solution will always be when theta is your theta or your denominator, or in this case here, the tan can also be part of a numerator. Okay? Not only the denominator. As long as it's there, whether it's a numerator or denominator, your identity will also be undefined for theta equal to 90 plus k times 180 degrees. So this is like a general solution now. But it's only for cases where the identity is tan. So once you see tan in an identity, be aware that that identity can be undefined if theta is 90, if theta is 270, theta is 450, and so on. Are you following that? Right. So make sure you're aware of that. Most learners, they tend to forget this one here. It's very easy to forget. So if you have to be very careful. If you get a question which has got a proof, okay, rather an identity, and the identity involves tan, and you're asked to determine values of theta or x such that the identity is undefined. As long as there is tan, whether in the numerator or denominator, this will be true. Okay? That will be true. Okay. So how do we apply that? Okay, you can understand it better if I do an example. Okay, please be aware that this part is still under the general solution. So it says, for which values of theta are the following identities undefined? Okay? So let's start with A1. So A1, you look at denominators on both sides of the equation. Can you pay attention? Because recently when the grade 12s wrote their March test, I put a question of this type, and it was a disaster. And this is taught in this grade, not in metric. You are taught this in grade 11, but next year you'll be required to know it. So you look at your denominators. You have got sine theta there, you have got sine theta. So there's no point of getting values for sine theta for both sides because it's the same denominator. So all you have to do is say sine theta is equal to 0. You equate the denominator to what? To 0. Then you apply your knowledge of the general solution. So this will be theta equal to shift sine of 0 degrees. Sorry, not 0 degrees, but 0. Plus k times 360, because there are many values of theta. There are many values of theta, both negative and positive, that will make that identity and to be undefined. So this will be theta equal to, now this gives you 0 degrees. Okay? Right, so the first solution is going to be k times 360 degrees, where k is an integer. Then the second one, because we have dealt with the first quadrant here, we need to get the general solution for the second quadrant. Are you following? Yes. Right? So we say or, then we say theta will be equal to 180 degrees minus the reference angle. Our reference angle is that. Remember, that's the reference. The value you get from your calculator, that's your reference angle. That's why you don't have to write it down, because you have it in your calculator. It's there. Right? Minus 0 degrees plus k times 360, where k is an integer. So you get the second general solution as 180 plus k times 360, where k is an element of z. Now, if you look at the question here, it doesn't give you any restriction for theta. Do you see that? Because there is no restriction, we leave our answers as general solutions. So that's the first solution, and this is the second solution. Yes? Yeah, because there is no specific restriction. That's when you substitute now the values of what? Of k, and use common sense based on the yes. Look here. If you have the resistance 0 to 0 degrees 60, obviously, like in this case here, you substitute k equal to 0. Right? If the 0 degrees is included, then it will be a solution. If you put k equal to 0 here, 180 will be a what? A solution. That's where the common sense comes in. Okay? You're laughing. Any question? No, this is very easy. I always wonder, okay, I'm going to show you something. In fact, I'm going to give you a grade 12 question, which came last year in the final exam. And you can do it, most of you here, if all of you can do it. It had 6 marks on the general school. It was so easy. But yeah, it did not involve any grade 12. It was a grade 11 one. I'll show you. That's not. Okay? All right. Let's move on to the next one. So the next one, you see we have got one with tan there. This one here. You see that one? Now, we don't have a denominator. Okay? We don't have a what? A denominator. Since we don't have any denominator, the trig ratio which is going to determine our solution, which will make the identity undefined, is going to be what? Tan. Now with tan, you don't stress. Okay? No stress. So your theta will be 90 degrees plus k times 180, where k is an integer. And please take note of this. If you go back here, right, you have to specify that k, is a what? An integer. Don't forget to write that, because that's very, very important. Okay, so k is an integer. So this will be your solution. Okay? There is no denominator in this identity. Therefore, tan is the one which determines the values of theta that will make the identity undefined. what is tan 0? Tan 0 is a 0, you know that. That's why when you sketch your do you know that? Tan 0, so tan 0 is a 0. That's why when you sketch, because you are still in grade 10 when it comes to trig graphs, you know that you guys are still in grade 10. So you have your 90 here, then 180, then we cannot talk about graphs without, trig equations and general solution without involving the graph of time. So when you sketch it, if you start from 0 to 360, you have an axis, you have a curve which looks like that. At 0 degrees here, the value of the ratio is going to be what? 0. The value of y is going to be 0. Then you have got another asymptote which passes through that. Then it goes like that. Right? Then you have, since you have got this top one above x-axis, you have got a bottom one which you can combine with that to form a full sine curve. Right? Don't worry, this is going to come back later on for grade 11. Yes, we are only doing part A of 3 parts of trig. This is part A. Part B is going to be trig graphs. Part C is going to be area, sine, and cosine rule. That's also application of trig. How about which line? From the graph, your trig functions. If you put values of x and your x is 90, your calculator will say error. You remember that? It will say error when x is 90.